Hi, welcome to Lesson 11, Session 3. Today we will be using adding on strategies to subtract. So it seems kind of funny to think about how we're going to be subtracting and finding the difference, but we'll be adding to do that. So anyway, I promise you it will make sense by the time we get to the end of the lesson about how you are going to add to subtract. So we're going to be in our Ready Classroom Math Workbook. We'll be on pages 215 to 220. So please go ahead and open your Ready Math Workbook to page 215. Okay, so we are on page 215. This is the session where we were adding on to subtract. So first we're going to go ahead and read this problem and solve it with the strategies that we have been given so far, where we are using addition to help solve the problem. So the problem says, Galen can reach up to a height of 1 87/100 meters while standing flat on the ground. His father can reach a height of 2 56/100 meters. How much higher can Galen can Galen's father reach? Use addition to help solve the problem. So first, what are we talking about? And we are talking about how far Galen and his father can reach. Now, what we want to know is how much higher than Galen can Galen's father reach. And then the important information is that Galen can reach 1 87/100 meters, and his father can reach 2 56/100 meters. So if we were looking at this and we had a line here, and we had, this is how far up Galen can reach, and Galen can reach up, and this is 1 87/100, okay? And then his father can reach this high, and this is 2 56/100 meters. What we're trying to find out is this space in the middle. What is the difference between what Galen can reach and his father can reach? And if we wanted, we know that the subtraction problem would look something like this. 2 56/100 minus 1 87/100 equals. This is how we would write it as a subtraction. But remember that the inverse operation of subtraction is addition. In other words, if we subtract something, we can add it back and get the original number we started with. So we can write a related addition sentence if we are going to use addition to help us solve this problem. So we know that if we have a total and we subtract a part, we're going to get a part as our answer. So that also tells us that if we take these two parts and we add them together, it's going to equal our total. So if we know that we have a part plus another part, it is going to equal the total. Well, we know the total, and we have one part. The unknown part that we don't know is this pink part right here. So we could rewrite this subtraction sentence as an addition sentence that would look like this. 1 87/100 plus something equals 2 56/100. So now we need to figure out what this question mark equals. So we're going to start with our 1 87/100. Now, I know that 87, I'm going to actually use pink, 87 plus 13, that equals 100. So 1 87/100 plus 13/100 equals 2 wholes. So then I'm going to move my 2 wholes down here, and I'm going to add to my 2 wholes. I'm going to add, how much more do I need to add to get up to 2 56/100 if I already have 2? That's right, I need to add 56 hundredths. And then 2 plus 56 hundredths equals 2 and 56 hundredths. So now all I need to do is add together these two parts to find out what my difference is. So 13 hundredths plus 56 hundredths equals 69 hundredths. So therefore, I know that this distance here is 69 hundredths. So 1 and 87 hundredths plus 69 hundredths equals 2 and 56 hundredths. So Galen's father can reach 69 hundredths further than Galen. But let's go ahead and look at the next page to see what strategies they show us on the next page, or if they use the same strategy that I showed you. So we're going to go ahead and look here. It says, we're going to explore ways to understand using the relationship between addition and subtraction to subtract decimals. Here's the same problem we saw on the last page. So one way we can do it is we can draw a bar model to understand the problem. This looks vaguely familiar. That's right. If we just took this book and we flipped it up on its side, it would look a lot like what I drew on the last page. It just, in this case, it's drawing how far Galen's father can reach and how far Galen can reach. And then here is the difference. Or when I did it, remember that's the pink part that I colored in on the other. So it says, use the bar model to write equations that represent the problem. So if we wrote a subtraction equation, we would know that if we had 2 and 56 hundredths and we subtracted 1 and 87 hundredths from this, that this part here is what's going to be left over, or D is the difference. Now, if we wanted to rearrange those numbers, making sure that we were adding a part to equal the total, then the related addition equation would be if 1 and 87 hundredths plus D equals 2 and 56 hundredths. Now, if we're looking at the model it section, we also could use a number line. You can use a number line to model adding on to find a difference. So we start with 1 and 87 hundredths. We recognized that if we add 3 hundredths, that will take us up to 1 and 9 tenths. Then, to get from 1 and 9 tenths to 2, we add a tenth. And then to get from 2 to 56 hundredths, we add 56 hundredths. So, and this down here just says what I just showed you. We start with 1 and 87 hundredths. We add 3 hundredths to get to 1 and 9 hundredths, or 90 hundredths. Then to get from 1 and 90 hundredths, we add 1 tenth to get up to 2 hundredths, because this is the same as 1 and 9 tenths. Plus 1 tenth is 2 wholes. Then once we have our 2 wholes, we add 56 hundredths to get up to our final total of 2 and 56 hundredths. Then we add together all of those parts to get our difference between 1 and 87 hundredths and 2 and 56 hundredths. So let's go ahead and go to the next page to answer some of the questions. Number 1 says, look at the bar model. Let's see if we can get to, all right. Look at the bar model and the addition and subtraction equations in Picture It. What does the letter D represent? So if we're looking at this bar model, what does this letter D represent? It represents the difference between the heights that Galen's father can reach and the height Galen can reach. What do the numbers 2 and 56 hundredths and 1 and 87 hundredths represent? The 2 and 56 hundredths is how far Galen's father can reach, and the 1 and 87 hundredths is how far Galen can reach. Now, if we're looking at the model the number line and model it, why do we start the number line at 1 and 87/100ths? Why is that where we start? You start adding on from the height Galen can reach to see how much farther his father can reach. So we're always going to choose the number that you're subtracting, or the lesser number, and then you're adding on to get to the larger value. So if we know that 1 and 87/100ths is less than 2 and 56/100ths. So we're going to start with the lesser value and then add on to get up to the greater value. How can you use the jump numbers above the number line to find the value of D? So these right here are called the jump numbers. These are the numbers that we jump up or we add on to get up to the total value of 2 and 56/100ths. So how do we use these numbers? This plus 300ths, plus 1/10, plus 56/100ths. Well, we're going to add them all together. If we add up all the jump numbers together, we find the total difference between 2 and 56/100ths and 1 and 87/100ths. So how much farther can his father reach? Let's add. We're going to add 0 and 300ths plus 1/10 plus 56/100ths. Well, 56/100ths plus 1/10 is 66/100ths. And then 66/100ths plus 300ths is 69/100ths. So therefore, we know Galen's father can reach 69/100ths more than Galen. So how can addition help you subtract decimals? So you can go ahead and zoom in and we can write this. It says, you can write a subtraction equation like this. The total minus the part equals the part. So this would be, in this case, it would be 256 minus 2 and 56/100ths minus 1 and 87/100ths equals, now we know, 69/100ths. But you can write this as a related addition equation. The part plus the part equals the total. So you start with the part you know. So we started with the 1 and 87/100ths. And then we added on to the total to find the difference. So we started, let's go back to my example that we used first. We started with our 1 and 87/100ths. We added on to get up to 2 wholes. Then from 2 wholes, we added on to get up to 2 and 56/100ths. Then we took all that we added on and added it together to get the total of 69/100ths. So if we're just looking at the two strategies we talked about today, we talked about drawing a bar model, we talked about using a number line, and then we talked about, I will just call this the adding on strategy. So we've got the adding on strategy, we've got the number line strategy, and the bar model strategy. Which of these strategies do you like to use best when you're using addition to subtract? Which still sounds funny to me. So when I use addition to subtract, the strategy I like best is because, so remember, you're choosing the adding on strategy or the bar model strategy or the number line strategy. Tell me the one you like best and then tell me why. Go ahead and pause the video now. Okay, go ahead and turn to page 218. Now I've already kind of gotten us started on page 218. I have added my number line so that we could, I could model the number line adding on strategy. So the question says, at a swim meet, Quinn's time for the 15-meter freestyle event was 39 and 3/10 seconds. Her sister, Darby, swam the event in 38 and 85/100ths seconds. How much faster did Darby swim 50 meters than Quinn? Show your work. So we are talking about a swim meet where they ran the 50-meter freestyle. That's what this question is talking about. What is the problem that we're trying to solve? We're trying to solve how much faster did Darby swim 50 meters than Quinn? And the important information in this question is that that Quinn swam it in 39 and 3/10 seconds, and Darby swam it in 38 and 85 hundredths seconds. So we're going to go ahead and use the adding on to subtract strategy. So remember that we're going to start at the lesser number. So we're going to start at 38 and 85 hundredths. And then we're going to add on to get up to this 39 and 3/10. But we don't know how much we add on. So we're going to jump up. So first, we're going to jump up just this tiny little bit. And this tiny little bit, each of these little tick marks is 1/100th. So we're going to jump up 1, 2, 3, 4, 5 100ths. 5 100ths. 5 100ths is going to get us up to 38 and 9/10. From there, we're going to jump up all the way up to here. Now, we're going to see each of these little tick marks, remember, is 1/100th. So every time we jump up 10 100ths, that's the same as 1/10. So we're jumping up 1/10, 2/10, 3/10, 4/10. So we're going to add 4/10 to that number. So when we go up 4/10, now we're going to take these two jump numbers and add them together to find out the total amount, the total difference between Quinn's time and Darby's time. So 0 and 4/10 plus 0 and 5 hundredths equals 45 hundredths. 4/10 and 5 hundredths. So the answer is that Darby swam 45 hundredths of a second faster. And that's how we use the jumping up method on a number line. Now for number 7, I'm going to use the place value method well, I lied. Let's go ahead and see what we're going to do here. So it says, Tamika has 2 guinea pigs for pets. Smokey weighs 39 and 73 ounces, and Tito weighs 42 and 25 ounces. How much more does Tito weigh than Smokey? Show how to solve the problem by adding on. So I wrote this problem. Well, first of all, let's figure out what the problem is talking about. The problem is talking about the guinea pigs and how much they weigh. We want to know how much more Tito weighs than Smokey, and we're going to be adding on to find this out. And the important information is that Smokey weighs this much and Tito weighs this much. Now I've written it as a subtraction problem, but we're going to go ahead and add on to subtract. So to do that, we need to rewrite this as an addition problem, or we need to start with the lesser value. So we're going to go ahead and start with this 39 and 73 hundredths, because that's where we're going to add on from. So if we start with 39 and 73 hundredths, how many hundredths does it take us to get up? Let's go to a tenth. So if we're at 73 hundredths, we need to add on 7 hundredths to make this the next tenth. So if we add on 7 hundredths, that's going to equal 39 and 8/10, because this 7 hundredths plus this 3 hundredths, we can regroup it and make another tenth to get up to 8/10. Then from 39 and 8/10, we're going to add to get this up to 40. How many tenths do we need to add to make this regroup to 40? That's right, we're going to add on 2/10, and then that will equal 40. Then from 40, what do we need to add on to 40 to get up to 42 and 25 hundredths? That's right, we need to add 2 and 25 hundredths. And then that will take us up to 42 and 25 hundredths. Now all we have to do is add all of these add-ons together. I'm actually going to go ahead and add them where they are. This is a 2/10. These two numbers have hundredths, so I'm going to put a 0 so that I can have all of my place values lined up. I happen to write them so that they all lined up naturally. So I'm going to add 7 plus 5, which is 12. That's 12 hundredths. So I'm going to put my 2 down below, regroup 10 of my hundredths, and make it another 10. Then I'm going to add 1 plus 2 plus 2, which equals 5. And then I'm going to add 0 plus 0 plus 2 equals 2. So I know that Tito weighs 2 and 52 hundredths ounces more than Smokey. Now, if I want to check my answer, I can go ahead and subtract the traditional way to make sure that my adding on strategy was correct. So let's see if we get this answer of 2 and 52 hundredths. Let's see. 5 minus 3 is 2. 7 minus 2, well, I can't do that, so I need to regroup and take away one of these wholes and add 10/10 to the 2/10 that I already have and make that 12. 12 minus 7 is 5/10. 1 minus 9 I cannot do, so I'm going to regroup. I'm going to make this a 3, add 10 ones to my 1 that's already here, which makes 11 ones. 11 minus 9 is 2. 2 and 52 hundredths, 2 and 52 hundredths. So my adding on strategy to subtract worked. So sometimes you might just want to do it this way, but you can always use the adding on strategy to check your work if you're subtracting, or if you use the adding on strategy, you can use the subtraction strategy to check your adding on strategy. Now, finally, number 8 says, which equation can you use to find 55 and 15 hundredths minus 47 and 29 hundredths? So remember, this is our total, and this is our part. And when we subtract those, it will equal another part. How can I rewrite this number minus this number, and then this part, they're calling it the letter N. Okay? So how can I rewrite this sentence to make it make sense? Go ahead and choose your answer. Okay, remember, I told you the part plus the part equals the total. So we need something that looks like this. 47 and 29 hundredths plus the part, or N, equals 55 and 15 hundredths, because that is the total. Do we have that anywhere? Yes, we do. Right here, letter A. Letter C doesn't work because we can't add the total to a part to get the part. Letter B doesn't work because we can't take the total. Oh, actually, we could do that as well. But that would work, because if we started, I know it wouldn't work, because we can't have the total and add a part to get a bigger number. So you can't add, I didn't see that. You can't add a bigger number to another number and get a smaller number. My bad. And then finally, you can't break this up and subtract, and that doesn't work. So the one that works is letter A. That's how we rewrite this sentence to make sense. With that, you're going to go ahead and do pages 219 and 220 on your own. If you have any questions, you can email your teacher. Otherwise, I'll see you soon.